So, good morning, everyone. Good morning, everyone.
Good morning, Ma.
Good morning, ma'am.
Morning. Good morning.
Yeah, we will
Good
wait for
morning.
5 more minutes for everyone to join. Then we will start today's class. Yeah, yes, Gauransh.
Ma'am, can you please discuss all the questions of the grade assignment of week 2?
Graded assignment of week 2.
Yes, ma'am.
Yes, ma'am. Graded assignment questions.
The submission date has been over, right?
Yes,
Yes, ma'am.
Yes, yes.
Okay, okay. Then
Prof,
actually, today,
the assignment for week 3 is very rigorous. So
yes, Noel, can you please repeat what you said now?
yes, Professor, the assignment of week 3 is very
Okay,
rigorous,
it's very
difficult.
okay. Graded assignment. You're talking about graded assignment, right?
Yeah, I mean the activities, the other assignments, they are not easy either.
Okay, okay. I will take your feedback and I will see what we can do about that.
Oh no, no. I mean, Professor, sorry, I didn't mean that. I mean this difficulty is, I mean, is good for us to learn.
Yeah, yes.
This course. You don't. I mean, this is good, but I just if you can have more like live session to explain those
Okay.
topics.
Okay, like you want more
Thank you.
live sections to explain and cover all topics, right?
Yes, yes.
Okay. Yeah, sure. We'll see what we can do about that. And regarding week 2 assignments, solving, uh, like we will have it at the end of the session. Okay.
Uh, but ma'am, can you please discuss the whole graded assignment? That would take a class also.
Okay. Okay. Give me a minute. So we will wait for everyone to join. Then we will discuss. Hello. Yeah, so yeah, today we will see about the week 2 graded assignments also. So there are total of 11 questions, right? We will go through each and then we will go to week 3 summary. It's fine, right, for everyone?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes.
And Noel, we will also look into that. We will see if we can discuss more practice problems and activity problem related to week 3, so that when you actually try graded assignments, it will be easy. So we'll discuss more related questions, so it will be easy for you guys. So we will discuss and we'll inform the other information in that Google Space. So yeah, uh, so around 42 students have joined. So we will start the session now. So before going into the sessions, so there are a few things I wanted to discuss with you guys. So have you guys submitted the handwritten assignment so for week 1 and week 2?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So yeah, so we went through a few documents submitted by you guys, and we saw some of you have done really good in writing the handwritten assignments, and few of you haven't put much effort in writing that. Actually, the handwritten assignments also have majority of marks carrying. So I hope you guys put your efforts in that also. So there are few students who have done really good. Like they wrote the roll number, they wrote the formula, then they wrote the steps, then they wrote the answer, and they wrote it in a format. So I hope you all guys will follow the same format from next time. So I will show you a model. So please follow the same. Like you can change the model also, but please make sure that the formula and the answer and the steps how you reach that is also there.
Ma'am,
So, yes.
This assignment is the one which is submitted in the Google Forms through the graded assignment, right?
Yes. Handwritten assignments. So I will share a document which has been submitted by one of you guys, and it's really good. So I hope you all guys for like. I don't want you guys. I don't want you all to follow the same format. I just want your PDFs to have certain important uh, things like the if you are starting a question, the formula it should be there, and each and every. I don't want each and every step, but the flow should be there, right? And then the final answer. And please write the question number also, and write your roll number and name inside the PDF also. So yeah, let's see. So this is the graded assignment week 1 answer submitted by one of your friends, and you can see, right? The handwriting is also clear. So the person who is correcting will be able to understand what that person is trying to tell and how he has reached the answer. And there is no need for you to write the questions and all. Just write the answer by writing the given or whatever in shortest form you can. Then write the formula and then write how you have solved it and then write the answer. It's enough. So if you can see this, you guys can see this PDF. This person has actually written all the formulas given and then the like steps and then the answer. And he has also highlighted the answer. So it's good, right? Once we see this, we can understand, right? Like okay, this is how he has solved and what are the steps he has followed. I hope this is clear, right?
Yes, ma'am.
Yes, ma'am.
And also, I have seen in week 1 and 2, some of you just written like question number 1, option A, then the answer. So there is no point in writing that, right? We wanted to know how you actually reached to that answer. So please write all the steps, and then so the steps are important. So we will know whether you have actually tried it by solving or you just ticked one of the answers. So please make sure that you write each and every steps. And also, if you guys have any doubts related to technical part also, like if there is a problem you can't understand, please post the problem in the Google Space also. Like you don't have to wait for live session. You can just post the questions. So whenever if we see that, we will solve and post the answers there. Otherwise, if you have more, then we will discuss it in the live session also. Yeah, Raghav.
Ma'am, the Google Space is the Google Groups wala?
Google Group.
Okay.
Once you open your Gmail, there will be a chat space, right? In that, you could see like there is the name of the group is ESGC May 2025.
Excuse me, ma'am.
Yeah, Gauranj.
Ma'am, in the last class, ma'am, I raised.
Yeah. I remember you asked me like you can't see the Google Space, right?
Yes, ma'am. But ma'am, still I can't see it.
Same here, ma'am. The Google Groups is there, but there is no space Google in the Gmail.
Yes, ma'am. Same here, ma'am.
Okay, the space is there, but you can't see the group, right?
Yes, ma'am.
Yes, ma'am.
So, okay, whoever is having the issue, everyone please write your names in the comment section. In the comment section, just write your name. I will take a screenshot.
Chat is disabled.
Yes, Raghav, what happened?
Chat is disabled. I can't write here.
Oh, okay. Then just raise your hands, no? I will note it down. Gauranj, I already so last time itself I mentioned like so there are many people, right? Like that.
Yes, ma'am.
Okay. Okay, I will inform them, and we will see what we can do about it. Yeah, you can put your hands down. Yeah, now we will see the graded assignments. You guys are able to see the screen, right?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yeah. So the first question is, we have to find the equivalent resistance in ohms seen between the terminals A and B. So as usual, I will give you 3 minutes for you to solve the problem. Then we will solve it together. Is it fine?
Yes, ma'am.
Okay. Or we can do this. Can anyone just one of you unmute your mic and tell here what are the resistors that are in series and how is it like the flow, how you will solve the problem?
Yes, the bottom right side, the 2 ohms and 2 ohms resistors are in series. So we can get the equivalent of it. It would be 4 ohms. And on the right hand side top, we can see 4 ohms and 12 ohms resistor. Both are in parallel. We can also get the equivalent resistance for parallel using the formula. And also on the left hand side on top, 6 ohms and 12 ohms resistor are also in parallel. And also bottom there, 4 ohms and 4 ohms on the left hand side, bottom left hand side, 4 ohms and 4 ohms. So this will be become 2 ohms, 4 ohms and 4 ohms in parallel.
Yeah, yes.
Ma'am, if you allow me to, then I want to show my answer.
Yeah, you can show.
Okay.
Like you have written it in your paper and you want to turn on your camera and show? Or how? Praveen, right?
Yes, ma'am. I have a PDF which I submitted as an assignment, and I will show.
Okay. But you have a doubt in this question?
Yes, I have a doubt in question number 11, and if you want, I can show this first question solution. I've written very well.
Oh, it's okay. Like we anyway we'll discuss, right? I just wanted someone to just tell so that if it could be a clue for everyone to solve, right? Then I will solve the answer. So yeah, now we will solve this together. Yeah, as one of your friends said, this 2 ohm and this 2 ohm are in series. So first, this will become as E, B, 3 ohm. At the same time, we will also arrange it in a such a way so it will be easier for us. 12 ohm. 4 ohm, and in this side of 4 ohm the 2 ohm and 2 ohm are connected, and next to 12 ohm another 4 ohm is connected, and here another one 4 ohm is connected. Yeah, do you guys agree that the diagram which has been drawn here is similar to this one?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, so what I did is just I rounded off the nodes which are the common nodes, and I reformatted the diagram in such a way where for me understanding whether the resistors are in series or parallel is like more visible to me. So if I see it like this, I will know this 2 ohm and this 2 ohm are in series, and the 6, 12 and 4 are in parallel. In the same way, this 4, 4 are in parallel. And then this combination is in this 6 ohm, 12 ohm, 4 ohm combination is in series with 4 ohms combination. Then it will be easier to solve in this way, right? So we will solve it. Our circuit will actually be reduced to this format. This is 3 ohm. So what is 1 by 6 plus 1 by 12 plus 1 by 4?
2 ohm.
It will be 2.
2 ohm.
Okay. It will be 1 by 2, right?
Yes, ma'am.
Yes, ma'am.
Okay. Here it will be 1 by 2. Then this 2 ohms and 2 ohms are in series. So this is 4 ohm. And this one is 2 ohm. And this one is 2 ohm. So again the circuit will be reduced as 3. Like this. 4, 4, 3. And this 2 will be 2 ohms. So the total is 5 ohms.
5 ohm.
Do anyone have any doubt in this problem?
Excuse me, ma'am. Ma'am, on the left hand side, the 4 ohm and 4 ohm are also in parallel, which is 2 ohm.
Okay, wait, I will number the resistors so that because I'm not able to understand which 4 ohm you are talking about. Yeah,
Ma'am,
now you can. Yeah, this 1 and 2 are in parallel, right?
And ma'am, they are in series with the 6, 12 and 4 ohm.
They are in series with the 6, 12 and 4 ohm. How?
Because on the 6.
Okay. See, there is a line here, right? Which is preventing this 4 ohm and 6 ohm to be in series. So how it is actually is, see, this one is 6 ohm, 12 ohm, 4 ohm, 4 ohm, 4 ohm, and this end of this 4 ohm is connected to this end of the 4 ohm, 2 ohm, 2 ohm. So like once I redraw the circuit, this is how the circuit is. Are you able to understand?
Yes, ma'am.
Yeah, who was asking that? Oh yeah, Gauranj, right?
Yes, ma'am.
So yeah, so the easiest way is just see. Once you find a circuit, round off the common nodes. Here, this one is a common node, right? And this one is a common node. And this is not a common node because this and this are the same point. Give some names A, B, C, D. In the same way here also, first write the points. A, B, D, and yeah. Then connect the resistors so that you will actually arrive to this circuit. Then for you, it will be easier to understand what are the resistors that are in series and parallel. Now, do you have any doubts?
No, ma'am.
Okay. For the first time, when you see circuits, big circuits like this, it will be very confusing for you to choose whether it is in series or parallel. But once you practice more, then you will be able to once you see, you will understand, okay, these two are in series, these two are in parallel with each other like that. Initially, it will be tough, but more you practice, you will be able to understand. For initially, you try like this, like use a round of the nodes, then give some names in the same, then redraw the circuit in such a way you will be able to understand it more. Then try solving it.
Okay, ma'am.
Yeah. So we'll now go to the second question. So there are two terminals A and B and three capacitors are connected in between. So with reference to the figure below, if each capacitor stores 1 coulomb of charge, the equivalent capacitance between the terminal A and B is dash. So you guys try solving for 3 minutes, then we will discuss the answer. So yeah, in this question, they are given charge of each capacitors they are given. That is 1 coulomb. I will just write it down. C1, C2, C3 are the three capacitors. For C1, C2, C3. For all the three capacitors, the charge is given as 1 coulomb. And also in the diagram, they are given the voltage. That is 2 volts. Here it is 3 volts. And here it is 5 volts. what they have asked us to find the equivalent capacitance. If we want to know equivalent capacitance, since this is in series, 1 by C equivalent will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. So yeah, so for us to find, so this is the formula, right? For us to find C equivalent, we need to know C1, C2, C3. For C1, C2, C3, they are not given the direct value, but they are given the charge and the voltage. From these two values, we can find C, right? Because there is another one formula, Q is equal to CV. So C is equal to Q1 by V1. C2 is equal to Q2 by V2. C3 is equal to Q3 by V3. So what is the value of C1?
It's 1 by 2.
1 by 2.
It's 1 by 2. C2 is 1 by 3 volts. C3 is 1 by 5 volts. Now, if I write in this formula, it will be 1 by 1 by 2 plus 1 by 1 by 3 plus 1 by 1 by 5. Is it right?
Yes, ma'am.
Okay, give me a minute.
I think it should be 1 by 1 by 1 by 2, ma'am.
Yeah, that's what I'm saying. If C1 is parallel to C2,
No,
1
ma'am.
by C
The
equivalent
IS
will be equal to 1 by C1 plus 1 by C2.
1 by 2.
Ma'am, 1 whole divided by 1 by 2
1
is equivalent to 2.
Yeah. Can you please repeat it again?
Ma'am, 1 whole divided by 1 by 2 is equals to 2.
That's
Similarly,
why
plus
1
1
by
whole
2 plus
divided by
1 by 3 plus 1 by 5 volt will be added, ma'am. I think.
Yeah, right. 1 by 2 plus 1 by 3 plus 1 by 5.
No, ma'am. Actually, it's ma'am. C1 is equals to 1 by 2. So 1 whole divided by 1 by 2 you should write, and it's equal to 2.
Yeah, give me a minute. You guys solve.
Yes, ma'am. We are already sorry.
Yeah. So yeah, now I understood. One by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Yeah, 1 by C equivalent will be equal to 2 plus 3 plus 5. Now C equivalent will be equal to 1 by 10, right?
1 by 10.
Yeah, so
Yes,
the
ma'am.
answer will be 0.1.
0.1.
Correct. Yeah. Yes.
Yes, ma'am.
Yeah. I missed the 1 by C equivalent here. That's why. So yeah. Then the third question is, give me a minute. I will copy paste the question. Yeah. So this is the third question. The potential difference VAB between the terminal A and B for the circuit shown below. Yeah, I'll wait for 3 more minutes. You guys try
Professor?
solving, starting it. Yeah?
Excuse me. Why this? Why I was wrong about this question. But why is 0? It's a voltage source, 12 voltage.
You're asking about the third question, right? Noel?
Yes.
Yeah, so you're asking about the third question. So, yeah, now tell me what's the doubt.
Okay, thank you.
Yeah. Hello?
Yes.
Yeah, you are
I mean,
asking.
I understand that if without the 12 voltage voltage source, VA equals VB. But the thing is that then, but there's a voltage source there. Why it's still 0?
Here, what? Here, the answer is not 0, right? What is 0 here? I don't understand.
So the answer is sorry, the answer is not 0. Oh, sorry,
Yeah,
I
it's
made
not
a
0.
mistake. Oh, sorry, I made a mistake.
So, yeah, in this question, we will try doing it using KVL. We will draw 2 currents inside, I1 and I2. In the question, they have asked us to find VAB, which is the potential difference between this point and this point, between the terminal A and B for the circuit shown below. So we will take loop 1, we will write one equation, and we will take loop 2, we will write one equation, we will solve it. Then what we are actually supposed to find is the potential difference between these points. So there, at this point there will be a potential VA, at this point there will be a potential VB, and between these 2 points there are 3 components. One is this 3 ohm resistor and this 12 volt and this another 2 ohm resistor. So we have to find the potential difference that is existing between these 3 including these 3 components, that is VA minus VB. VAB is nothing but VA minus VB. Yeah. So first, we will start writing. Hello, are you guys there?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, just tell me when I'm like if I am explaining what I'm explaining is too confusing. So basically in this question we have to find VA minus VB because we have to find the potential difference between these terminals. So VA minus VB. So there are 3 components here. One is 12 volt, 2 ohm resistor, and another one is 3 ohm resistor. To find the potential difference, we need the voltage consumed by all these 3. This 12 volts we know because it's already given in volt. Whereas this 3 ohms is in resistor and this 2 ohm is in resistor. Now we need to find the voltage here and here. For that, we have 3 ohms, resistor is there. We know V is equal to IR, resistor is there. So we need to find the current. That's why we are going to this KVL where we are writing the loop I1 and I2. Now, are you able to understand why we are going for
Yes,
KVL
ma'am.
here?
Yes, ma'am.
Yes, ma'am.
Yeah. Now we will write the equation for loop 1.
Excuse me, ma'am.
Yes.
Ma'am, if we do not use KVL and ma'am, we directly apply Ohm's law by dividing the circuit into 2 parts, by taking the one part as the A, where we are given a point A, and the other part as point B. and then we add the resistors 3 by applying V is equal to IR. 6 is equal to I into 3 plus 3, that is 6. Then I is equal to 1 ampere. And in the other part, 12 is equal to I into 2 plus 10. Then I is again equal to 1. So, ma'am,
Yeah.
you would get
Yes.
the value of I1 and I1 and I2 directly without applying KVL. That would be
Yeah, you can do that also.
much
Because
easier.
the answer is correct.
And ma'am,
Yes,
then
ma'am.
and ma'am,
Even I also follow the same approach.
and ma'am, then can we find the the potential difference across the 3 volt and the 2 volt, and then the answer would be subtracted. But
Ma'am, please solve this question, and then after take the.
Yeah. Okay. Gaurav, you will first. I'll just
After
explain
solving this,
the
then
basic
take
way.
response of this
Yeah,
student.
I understood. Yeah. Gaurav, but what you said is also right. For finding the current I1 and I2, we can use the method which you proposed also. It's fine.
okay.
Because you will get the answer. The answer is I1 is equal to 1 ampere and I2 is equal to 1 ampere. So yeah, once I will solve in this method, then I will come to that doubt. Okay.
Okay, ma'am.
6 is the voltage increase, so I will put it as plus. Then the current will be dropped across this 3 ohm resistors, so minus 3i.
Minus 3i.
Then again, yes,
Minus
it will be
3i.
dropped against the resistor 3, so it is minus 3. So 6 is equal to 6i. It's I1, right? I1. Then I1 is equal to 1 ampere.
1 ampere.
Whereas in loop 2, 12 minus 2i2
minus 2i2 minus 10i2.
minus 2. Oh yeah, minus 10i2. So 12 minus 12i2 equal to 0. I2 is equal to 1 ampere. So yeah, what Gaurav said, by his method also we got the same answer, right? So yeah, what he proposed said was also right. We can also try that formula also. Now, but the actual question is we have to find VA minus VB. For that, we will consider this thing. How it is given A point. There is this 3 ohm. In this 3 ohm, the current is I1. Then there is this 12 volt voltage source. Then there is 2 ohm. In the 2 ohm, the current is flowing in this direction. In 3 ohm, how is it flowing? It is in this direction, right? Because, yeah.
It's in the opposite direction. Yes, ma'am.
Yes. Now, for this circuit, we'll write the equation. At A, the voltage will be VA. The current direction is in opposite direction. So it will be minus of minus 3i1. Here the 12 voltage source will again be minus 12 plus 2i2 minus VB is equal to 0. So VA minus VB equal to 3i1. Here it will become plus. So here when it comes, it becomes minus plus 12 minus 2i1, I2. Right?
Ma'am, can you please explain one more time this equation?
Ma'am, that would be minus 2i2.
Yeah,
And
right?
there is a voltage drop. Yes, ma'am.
Minus 2. Yes.
Yes, ma'am.
Yeah. So it will be 11. Yeah. See,
Yes,
the
ma'am.
same question, I will explain it again. So there is a 6 volt connected with 3 ohms and 3 ohms. Then in this point, there is a voltage source. Then again, there is another one circuit. So what we did first is, we applied KVL. We did I1 in one loop, I2 in another loop, and we found the current I1 is equal to 1 ampere and I2 is equal to 1 ampere. Do anyone have any doubt how we reached to this I1 and I2? No, right?
No, ma'am.
Yes, ma'am.
Yeah.
No, ma'am.
So the actual problem arises when we are going to find the VA minus VB. If we see the circuit, I will consider these 2 points as A and B. This point and this point. First, I will write the points. Then there is this 3 ohm resistor that I will mark. Then this voltage source that also I will draw. And then again there is a resistor which is this 2 ohms. Because see, these are the 3 components which are connecting this A and B. And the first resistor is 3 ohm, the next voltage source is 12 volt, and the other resistor is 2 ohm. And if you see, the first I1 is flowing towards the upward direction, towards A. So I will mark it as like that, I1. Then again, I2 is flowing towards downwards, towards B. So I2. And we know I1 is equal to 1 ampere and I2 is equal to 1 ampere. Now, we will write the equation for this particular circuit. Since we have drawn it clearly, now we know VA is the starting point and this one is the ending point. From VA, I will assume it is positive. Then across the 3 ohm, there will be a voltage drop, right? So I am putting minus, but the current direction is in the opposite direction. So I will put another one minus, then 1 ampere into 3 ohms. Then this voltage source, it is in, the plus is in this side and minus in this side. So I'll put it as minus 12.
There is a voltage drop. Yes, ma'am.
Yes. So then again there is a 2 ohm resistor. There is a I2 that is happening. That is flowing through the 2 ohms. So 1 into 2 minus VB is equal to 0. And now I will ask a question. Why I am writing plus for VA and minus for VB?
Excuse me, Professor.
Because
Yes.
that is
Yes.
opposite in
Ma'am,
direction, ma'am.
ma'am, we can
Yeah.
also write it as equal to VB. Then when the VB will come this side, then it will be negative. We can say like this
Yes.
also.
So
I
before
have a
writing this
question,
equation, yes.
Professor. So firstly, it's a conceptual question. So once there's a 12 voltage source, so there's no current running through it. Does it mean that?
Oh, so you're saying that across this 12 volt voltage source, there is no current running through it, right?
Yeah. So so it won't change the current running. I mean.
Yeah.
So. Okay. And
no, I
second.
understood your question. See, in this question, if I ask you what is the current flowing through this 12 volt voltmeter, then the answer is sure. The current through it is 0 because the circuit is not closed, right?
Yes, ma'am.
Yes. But the question here is the potential difference. Each point will be maintained at some potential. Now they are asking to find the potential difference, right?
Yes.
Just like in this question, how this point and this point has some potential and its difference is 12 volt. Now this point and this point will also be having some potential.
Yes.
Can we find the potential at A and B individually?
Yes. Now coming back to my question, I'm asking why in this question A is put as positive and B is put as negative, and why for one direction of current I am putting it as negative and another direction of current I am putting it as positive.
Ma'am, why you take 12 as a minus?
Yeah, that's the question
Yes.
exactly I'm asking.
Why? I have the same question. Why it's 12
Yeah,
minus?
because for finding this question, I took at this point VA and VB and I assumed the total current is flowing towards this direction. Okay.
Positive to negative.
Yes. So I am considering this as positive and this as negative for my assumption. So if you see this current I1, it is flowing in the opposite direction. So since it is flowing in the opposite direction to my assumed current, I am putting it as negative. Whereas this I2 is flowing towards the same direction as my assumed current, I am putting it as positive. Now, if you see this 12 volt, normally in a voltmeter, like towards a voltage source, sorry, I told it as voltmeter, it's a voltage source, the current usually flows from positive to negative, right? So conventionally, the current should be towards this direction, but in this, I assumed it to be in the opposite direction. So I'm writing it to be like this. Now, are you clear? with the signs in this question?
Yes, ma'am. Understood.
Yes.
So yeah,
Professor.
I will just draft it again so that when you guys see this PDF later, it will be understandable. This I1 is equal to in 1 ampere. This I2 is in 1 ampere. This 12 volt. We are finding the voltage difference between these 2 points. I am assuming this is the general flow of IT. So that VA minus VB, I have to find. IT is the direction of current, I have assumed. For that, we have written this equation. And this is the answer. So yeah. So next time you come back to this PDF, please refer this highlighted diagram so that it will be easier. So yeah. Now we'll go to the next question. The next question is, the current in a coil linearly increases from 0.4 ampere to 1 ampere in 2 seconds. During this voltage across the coil, the voltage across the coil is 60 millivolt. The inductance of the coil is dash millihenry. Yeah, you guys can solve it for 3 minutes, then I will solve it again.
Ma'am, in this previous question, can't we do it as by point potential method? Like if we assume the point before the 12 ohm voltage source as 0, then we take 12 volts plus the voltage source 12 volts, then the point before VA across the 3 ohm resistor will be 24 volts. Then if we apply V equal to IR, then there will be a voltage drop of 3 volts, and A point it will be 20 it will be 19 volts, like that. Can't we do it like that?
So what is the voltage you got at the points? At which point?
Like if we assume 0 volts before the in loop 2 before the battery, 0 volts.
Before the battery, here?
No, ma'am, that other side.
Oh, here. Okay.
Yeah.
You want to assume it is 0 volts here?
Yeah, here.
Okay.
Then it will be 12 volts, and after the voltage source in the loop 1 where it is connecting, it will be 24 volts.
Here?
Yeah, ma'am.
Here it is 24 volts.
Okay, so if we go the upside towards VA, there will be a potential drop of 3 volts according to V equal to IR. Then at VA it will be 21 volts.
Actually, wait. Wait. You want to say that here it is 24 volts, right?
Yeah, ma'am.
How?
Like there's 0 volts and then 12 volts here and 12 volts here, so it will be 24 volts. That's, ma'am,
Okay.
I'm asking. Is it
here
correct?
it is 12 volts. And here I don't understand how you reach this conclusion that at this point it is 24 volts.
Like there's 12
Okay,
here.
see, okay, adding that and telling, but see here, this is also connected to the positive, then it should be 6 volts here, right?
Yes, ma'am.
It doesn't work like that actually.
Okay.
Because see, this is in parallel connection, right? It's not actually this circuit is not actually an exact parallel circuit. We can't assume that at this point it is 6 volts and at this point it is 12 volt. And this voltmeter is having a different value. So it is better to go through this method itself.
Okay, thanks.
Excuse me, ma'am.
Yes.
Ma'am, in the last equation, the diagram which you showed, ma'am, for this question only.
Yes.
Ma'am, if we apply nodal analysis and by taking the 12 volt at the center and our two currents are passing through them in the opposite direction, I2 and I1, can we not find the answer?
Okay, you want to do a nodal analysis?
Ma'am, for the last diagram which you showed for this question. Simplified.
What is the answer you're getting when you do that?
Ma'am, actually, I'm not able to solve that equation. That's why I was asking if it is possible. or I am just looking the equation wrong?
You want to put a point here, right?
Ma'am, I'm taking the 12 volt as a center point, and from there, uh, the I1 and I2 current are going in the opposite direction. So
Okay.
I'm making the equation.
Wait, I will try solving like what you are trying to tell. You took this point as plus 12.
Yes, ma'am.
This is 2 ohms. This is VB. Right?
Yes, ma'am.
3 ohms. Then if you see this, according to KCL, I1 will be equal to I2. Yeah, we are getting 1 ampere is equal to 1 ampere. But you want to write it as like a voltage equation. 12 minus VA by 3 equal to 12 minus VB by 2. Yeah, like this you want to write, right?
Ma'am, it would be equal to, or ma'am, like both the currents are going outwards. So ma'am, would it be plus
Yeah.
the
Yeah, it will be plus, it will be equal to 0, right?
Yes, ma'am.
Yeah, what's the answer you're getting? Like, I don't know whether it is correct or not, but let's try it out and find out.
Actually, I'm not able to solve that. It's getting.
Yeah, then we will try this at later, no? For now, we will stick with this.
Okay. But ma'am, is this method correct? I just wanted to.
I don't know, like whether you can take this voltage source as a point. Usually, when we go for a KCL, there will be at least 3 nodes. We will take a point. Here, I thought it like taking VA minus VB is easier, so I went with that formula. Okay. Because see, in this equation, wherever you take a point for KCL, the rule is already being satisfied. I1 is equal to 1 ampere and I2 is equal to 1 ampere.
Yes, ma'am.
But yeah, you can try. You can try using this formula also. Maybe you might get the answer.
Ma'am, the method I talked about that you said is wrong. Conceptually, it's wrong. I agree. But I am getting the same answer as 11 volts by that also.
Okay. So yeah, someone has tried and he told like he got the same answer.
Okay.
When you do calculation for this, it will become complicated. Like 2 VA minus 3 VB by 6 is equal to 10. Then you have to find, our goal is to find VA minus VB. So yeah, you have to solve it for a long time. Yeah, I can try. So yeah, now try solving the next question, fourth one. So what they have given is current increases from 0.4 ampere to 1 ampere in time 0 to 2 seconds. During this, the voltage is given as 60 millivolt. Then they have asked for inductance. So what's the formula for voltage in an inductance?
Voltage is equals to inductance into.
Yeah.
And
We can write it as V dt is equal to L di. Then we will integrate. Time is from 0 to 2, whereas inductance is from, current is from, di is from 0 to 1. So directly we can apply, right? 2 minus 0 is equal to L log 1 minus 0.4, voltage 60 millivolt. What is the value of L?
$200 million.
100 million.
Yes. Are you guys getting the answer?
Yes, ma'am.
Yes, ma'am.
Yeah. So yeah, in this question, they are given the voltage they are given, inductance you have to find, For DI, they said like current is varying from 0.4 to 1 ampere and time is like in 2 seconds. So you want to write it graphically, time 0 to 2 seconds. It is varying from 0.4 to 1. So for that, we are now integrating. Now TT is from 0 to 2, whereas current is increasing from 0.4 to 1. If we write it, and since it is just direct integral of dx is equal to x, because differential integration will get cancelled, now we are getting this. Now since here it is y1, okay, I will write y2, y1. This will become y2 minus y1. You are aware of this integrations, right?
Yes, ma'am.
Yes, ma'am.
Yeah. The same thing we have applied here. So we will get the answer L is equal to 200 millihenry. So yeah, now next we will go to the next question.
Ma'am, can you tell me the answer for the third question?
Third question is 11.
Okay.
Yeah. So this one, the value of the voltage source which causes the current I1 to be 0 for the circuit shown is. This circuit is for KVL, right?
Yes.
You guys can write the equation 1, 2, 3 equations because of the 3 loops. Then we will go to the question where the I1 is 0 they are given, right? That we will find it out. So first we will start from writing the equation for KVL. Yeah, just tell me the equation. So let us consider this is the first loop. Tell me the equation for this first loop.
Plus 20
Plus 20
minus 6I1
minus 6I1
minus 2 whole into
Yeah.
I1 minus I2 minus 5 whole into I1 minus I3.
Then
Equals to 0.
Then there is this component, right?
Minus V
Minus V.
equals 0.
Yes, ma'am. Minus V.
Yes.
Sorry.
Yeah.
Equals to.
Yeah, it's okay. Yeah, now the second loop.
Minus 3I2.
Minus
Minus
3I2.
Yeah.
Minus I2. Minus 1 into I2 minus I3.
Yeah. Then
minus 2 into I2 minus I1.
Yes.
Equals
to 0.
Yeah, now the third one.
Minus 4
minus
I3
plus V
It's
plus 5 bracket
So
I1
minus-
minus I3
minus 5 whole into I3 minus I1
plus I2 minus I3 or I3 minus I2.
Yeah. Right? You guys wrote the same equation, right?
Yes, ma'am.
Yes.
Yes, ma'am.
So yeah. So if we see these three equations, here what are the unknowns?
I1,
I2,
I2, I3,
and V.
V.
and here 3 equations. But in the question they are given I1 as 0. Right?
Yes, ma'am.
When I use this volt, the current is 0. So since this has become 0, now the unknowns will become 3, equations will become 3. So if we solve this, we will get an answer for I2, I3 and V, right?
Yes, ma'am.
Yeah, just solve me and tell me what are the answer for I2, I3 and V. If you guys have any doubt in how this equation is framed, then you guys can ask me. Are you guys getting the answer for I2 as 20 by 27? And I3 is,
Yes, ma'am.
yeah, same, right?
And
20 by
120
27.
by 27.
Yes, ma'am.
Then the answer of voltage is
43.70.
43.7. Yeah. I'll give 5 more minutes. Try solving it and see whether you're getting this answer. If you're not getting the answer, just tell me. We'll solve it together.
Professor, sorry, could you please explain question 9?
Question number 9.
Yes.
We're going in order, right? Yeah, the same like for a circuit shown below, the voltage in V across the 5 ohm resistor with the polarity. We have to find the voltage. One second, give me a minute.
Ma'am?
Yes?
Till when is this class, like the maths class is also starting?
Okay, I'm not aware of the timings of maths class.
10 to 11.
Like it's going on right now, it's just started at 10.
Okay. Now you have maths class also.
Yes, ma'am.
Yes, ma'am.
Yeah, so then we will end this meet, no?
Ma'am, I have a quick doubt about question number 11. The answer of the question number 11 is 7.5
Yeah, guys, if you
millivolt.
have maths class, then you guys can leave now. And those who have doubt, they can stay.
Okay, ma'am. So can we jump to the question number 11?
Question number 11. Okay. Yeah. A 4 millifarad capacitor. Yeah. What's it out there?
Ma'am, the answer is the 7.5 millivolt. If we convert a millivolt to the volt, it will be 0.075. And if we round off up to 2 decimal place, the answer will be 0.01. So I choose the 0.01 as an answer, but it will be shown me wrong that but I am the correct, because the in the instruction given the round of the
right.
decimal. Yes, ma'am.
The rounding to 2 decimal places, like it was given in the beginning of the graded assignment, right?
Yes, ma'am. Yes.
It was given for all questions.
Yes, ma'am.
Yeah. Okay. So maybe we will. Okay, I will discuss that with, and I will tell you.
In the written solution, I've done all the steps, step by step, all the steps.
Oh, yeah, sure.
And please consider this.
Yeah, sure.
And please,
I'll discuss and tell you.
Ma'am, will you please explain this question also?
Which question?
Ma'am, the 11th one only.
Yeah, sure. Like now, okay. See, we will explain each and every questions. Otherwise, we will release a solved one also. Like we will release a PDF where it is solved. So you guys don't have to worry. And Noel, you are asking about the 9th question, right?
Yes. Yes.
So if you
And
see the
y
9th
is
question,
0.
yeah, see if you see the two set, like, okay, I will screenshot and put it here. Yeah, actually that's a good question. See, if you see in this question, the 5 volt is at this point, right? Here it is 0 volts. In the same way, 10 volts, 0 volts. So that's the reason the voltage here is given as 0 volts.
It is hard. Okay, I understand now.
Yeah, your doubt is clear, right?
Yeah. Now I understand. Yeah. Okay.
Yeah.
Ma'am, we can also say it as that the current flowing through the 5 ohm is 5 ohm resistor is 0. Uh, so the voltage will also be 0 as the current is not flowing through the resistor. Then it means the terminal potentials are equal.
Yeah, your explanation is also right.
I mean it's short circuit. The potential difference between two terminal is 0. So it should be 0. So,
Yes. I just wanted to stick with the same way how we followed in the previous question. So,
yes.
yeah, what you said is also right.
Ma'am, can you please explain like why it's 0?
You want me to explain it again? Why it is 0 volts?
Yes, ma'am.
Yeah, Gauraj. If you see 5 volts, this voltage source says the voltage across this one. Okay,
The 2
I'll draw
ohm
it again.
resistor.
5 volt, 2 ohm, and there is this point. $10 volt, 3 ohm. C. You can also put K like current equation. If you see that this 5 volt, it is a potential increase. It will be dropped here itself, right?
Yes, ma'am.
And at this point, it will be 0 volts. Do you agree that the point here is 0 volt? Or do you have doubt in that? If I write a circuit like this, normally I will take it as a ground, which means why do I take this as a ground and say like at this point it's 5 volt? Since it is 5 volt, at this point it's 0 volt. The same concept has been used here.
Okay.
So this point is now at 0 volt and this point is also at 0 volt. So the resistor here, it is maintained at the, like what your friend said, it is maintained at the same potential at both the sides. So
Because
it's
of
a short circuit.
Okay.
Yeah, do you like there are a few more questions which we have to discuss, like 6 to
Ma'am, I have a question doubt in the question number 10.
10. Okay, that KVL, KVL question, right?
Ma'am, the resistance question is the 10th question.
Yeah, I'll discuss the 10th and 11th. Yeah, so this one is like same, like you have to write I1, I2, I3, write the equation, KVL equation for 3 loops, then solve for I1, I2, I3. Then what they have asked for the current I in the direction, right? Which is this one. That direction I1, I will be equal to I2 minus I3. So what's your doubt in this question?
Ma'am.
Since the time.
Ma'am, we can also do one thing in this question. We simply remove this 10 ohm because from the 10 ohm there is no current because it's short circuited.
Yeah, ma'am,
Why are
that's
you
how I
telling?
did it.
Why is it short circuited?
Because from the 3 ohm the current will be current flow from this wire, not from this 10
But
ohm.
this point and this point are is the same potential, right?
No, ma'am,
What
consider
you're
a
saying is
current is
only.
flowing through the 12 volt battery. It will go to the 3 ohm and the 12 ohm. And from the 3 ohm, the all current will go from this wire, not from the 10 ohm.
So what you're telling is that I1 will be 0.
Yes, ma'am.
Yes, ma'am.
There is no
The current
from
will
the.
go the path with the least resistance now. So it will go the path in below 1, not with the 10 ohm resistor.
Yes, ma'am.
Yeah.
Excuse
If
me,
you
ma'am.
solve also, you'll get as
So we can
I1
reduce
equal
the
to 0.
circuit.
Yes. So what you're doing is the easiest way to solve this. Okay, yeah. Like that also we can do. But if you write KVL also, you will get I1 is equal to 0. You solve.
But this will be lengthy.
Yeah.
Excuse me, ma'am. But ma'am, why would the current not go into a 10 ohm? Because ma'am, 10 ohm is the higher resistance because of that.
But
Ma'am,
see
according to
this.
me, it should go because ma'am, it's a continued loop. Because when the current would flow from the 12 volt, first it would have had two paths. One is the 3 ohm and other is the 12 ohm. And from the 3 ohm, the current should go like from the 10 ohm and back to the 3 ohm, and the wire which is like joining the 3 ohm and 3 ohm could be overlapped for a 10 ohm.
Wait.
If you overlap, you'll get like parallel connection. One will be 0 and one will be 10, and then the net resistance will be 0. No?
Wait. I'll redraw the circuit. 12 volt. 12 ohm. 2 ohm. There is a 3 ohm. 10 ohm. Okay, wait. I don't know whether we can take it as a short circuit. Wait, I will analyze the circuit and tell you. Okay.
Okay, ma'am.
3 ohm will be like this. In the same way, this connected to a 10 ohm. Then again, another one 3 ohm is there. And this short circuit is between the end of this 3 ohm.
Yes, ma'am.
And the end of this 3 ohm, right?
Yes.
Yeah. Yes. Now the 10 ohm will be ignored because the end, like, yeah. Now I am. Yeah. Someone was asking the doubt, right? Like why it is short circuit.
Yes, ma'am. I was asking about it.
Yeah. See, if you draw the same circuit like this, you can see that the current from here will flow here. Okay. At the same way, it will be separated here. The current will flow here and it will be separated in two ways, and this one will be coming back and this. Okay. In the same way, at this node, if you see, there is a path which has 0 resistance and there is another path which has 10 ohm resistance. So the current will naturally not flow in this way, but will go through this 0 resistance path. And then it will connect with this 3 ohm resistance.
Ma'am, it will not flow in the 10 ohm resistance because of the high resistance. That is the reason.
Not because 10 is high, it's because in this path has 0 resistance.
Okay, so then the current would take the easy paths for the flowing,
Yes.
where it is not facing any disturbance or any
Yeah.
decay.
Okay, I will explain it in this way. If there is a 2 ohm resistor here and there is a 3 ohm resistor here and there is a 5 volt and I am assuming this is I1, then what do you think this I2 and I3 will be? Otherwise, I'll make it as simpler. I'll take it as 1 ohm and 2 ohm. Yeah, we'll calculate 1 by 1 plus 1 by 2. This is nothing but what will be the answer?
1.5.
2 by 3, right?
Yes.
2 by 3.
2 by 3 is the equivalent resistance. Am I right?
Yes, ma'am.
Yes, ma'am.
What will be the current I1?
Five, 15 by 2.
15 by 2.
Yeah, it will be
15 by 2.
7.5. Right?
Yes, ma'am.
Yes, ma'am.
Yeah, now find I2. I2 is nothing but 1 into 5 volts, right? It will be 5 volt. Whereas I3. I3 will be 2 into 5 volts.
2 into 5.
Is it 2 into 5 volts?
No, ma'am. It's a 7.5 into 2.
It will be like
No,
5
no, no, no,
divided
no.
by
Sorry,
2.
sorry, sorry.
2.5 volts, right?
Yes, yes, yes.
Yes, ma'am.
Yeah. From this diagram, what we are concluding is when the resistor in this particular circuit is 1 ohm and when the resistor is 2 ohm. When it is 1 ohm, both are maintained at same potential, whereas the current is 7.5 it's not 5 amperes, right? Whereas at 2 ohm, it's 2.5 amperes. So what are we concluding? When the resistance is low, current flowing is more when the voltage is constant. Right?
Yes, ma'am.
So, in this, both are having the resistance value, but when the same potential is applied across both the resistance, if the resistor is less, the current is more. Whereas the resistor increases, the current will be decreasing. So, this is a general concept. In the same way, if this wire is an ideal wire which offers resistance is equal to 0 means, then all the current will be tending to flow through this zero resistance path. Right?
Yes, ma'am.
Yeah. Now you're able to understand, right? Why it is ignoring the 10 ohm path and flowing through the low resistance path, because that's the curve of the that's the characteristics of the current. It usually passes the path which offers zero resistance.
Okay, ma'am.
Yeah. What else questions you guys have out? We'll just
Ma'am.
I'll discuss how. Yeah.
Ma'am, please go to simplified circuit.
Yeah, your voice is not very audible. Can
Ma'am,
you please?
Ma'am, please show the circuit, simplified circuit.
Simplify for a second for the same question, right? This one.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Ma'am,
Yeah.
after it being short circuited, we can say that 3 ohm and 3 ohm are in series, right?
Yes, yes.
Yes, yes.
Then it will be 6 ohm. Then the
Yes.
whole 6, then that 6 ohm is parallel to the 12 ohm, right?
Yes.
Yes.
Then it will be 4 ohm, and this 4 ohm and 2 ohm resistor is in series. That will be 6 ohm.
Yes.
Then
So,
by this method, we can, using the Ohm's law, we can we can directly find the current, right?
yeah. Yes.
Which will be 2 ampere, right?
Yeah. Actually, this
Okay.
method is actually easier than the method which I said.
Yes,
Like
ma'am.
I
Yes,
wanted to
ma'am.
write KVL, right? But this one is very much easier.
Yes, ma'am.
Ma'am,
Yes.
ma'am, please consider the question 11th, which I told earlier that I correct the I mean I wrote the
Yeah.
answer 0.01.
Yeah. Sure. That I noted it down.
Please give me your mail ID so that if you forgot, I will remind you.
It's okay. I'll remember. Don't worry.
Please, ma'am. I got 80 marks. If this question is improved, then my marks
Yeah. I will
is
discuss
90.
yeah. Actually, the
Ma'am,
thing is, like in the
actually,
beginning of the question, you're telling like they have asked to round it off to 2 digits, right?
Yes, ma'am.
Ma'am, in the
So
graded
I saw
assignment
that in
one. Sorry for
the thing is
ma'am.
like wait 1 second.
Okay, ma'am.
In my portal, it is not visible to be taken in 2. That's why I was like, I'll discuss and I'll tell you, right? Is it okay, right?
In the assignment, in the graded assignment where we have to solve all the question, in the top of that, it is written that truncate the at the 2 decimal places. That is
Okay,
the
yeah. In my portal,
minute detail.
in my portal for week 2 assignments, it's not there. So I'll just confirm and I will let you know. So yeah,
Okay.
Otherwise, in the next meet, you can ask me the same question again. But don't worry, I will remember.
Ma'am, about the handwritten assignment submissions, like how can we know that our handwritten submissions are like approved or like checked and it's like proper? Does the marks indicate that if like in the grades it says your score and then 100? Does that mean my handwritten
So yeah.
assignment?
Actually, first you will get the marks from the answer which you have submitted in the portal. Then again, your handwritten assignments will be graded. Then those assignments will also be added to that already existing grade.
Like where will it be visible, ma'am, and when?
Okay, that I will ask and let you know.
Yes.
But the first week, if you have done very good and few of the handwritten assignments are like not very up to the point, they have written just the answers. So that's not the right way to do. So like now I showed in the beginning of this lecture, I showed you an example, right, where one person has written with if there is basic steps, then you will get the mark. So you don't have to worry about that.
Yes.
But make sure your handwritten assignment is submitted and it is like proper. The formula should be proper and the steps should be proper. Yeah.
Ma'am, when I will we get a response for question number 11?
When you will get response for
question number 11?
Yeah. I thought, wait.
Ma'am, can you please explain that question also, the question 11?
Yeah, that one. So yeah, a 4 millifarad capacitor has a current waveform as shown. If the initial voltage across the capacitor is 0, the voltage V across the capacitor at time t is equal to 2 milliseconds. So what is the formula of Vc of t? It's 1 by C I dt, right?
Yes, ma'am.
Do you guys have any doubt with this equation?
No, ma'am.
No, ma'am.
Yeah. So I is there, T is there, and the capacitor, what we have to find, C has also been given, 4 millifarad. If you want to find the integration of I dt, it's just the area under the curve, right?
Yes, ma'am.
So what's the answer you're getting? Just find the area, no?
0.0075.
The final answer is 0.0075. What is the area under this curve?
30.
2 into 15 plus 2 into
Ma'am, only until 2
Ma'am,
milliseconds.
we actually have to find from 0 to 2 milliseconds. Yes.
Yeah,
ma'am.
okay. Yeah. So what's the area?
30
into 10 to the power of minus 6.
So 30 by 4. Okay, 30 minutes. It's right? If you carry 30 by 4, if you do, what you will get?
What you will do, we'll take common the largest power.
7.5.
Yeah, but they have asked the question in millifarad, right? I mean milli they have asked.
In the voltage, that's.
Wait, I'll see the unit.
Ma'am, actually you have to write that 30 into 10 to the power minus 6, which will be equal to 3 into 10 to the power minus 5, and whole divided by 4 into 10 to the power minus 3 farad.
Yeah. Time is also in milliseconds. Okay. Yeah. So if you calculate, you will get the answer, right?
Yes, ma'am.
Yes, ma'am.
So is your doubt is clear? Is your doubt clear?
Yes, ma'am.
Yes, ma'am.
So yeah, wherever if it is a single integration I dt over an integral 0 to time, then just find the area of the curve.
Okay, ma'am.